Dexter is an open source, 7-axis, 3D printed, high precision, low cost robot platform. Dexter, I mean, the name comes from, human dexterity.
We think it was anything a human can do, dexterity-wise, is what we want to capture with the robot. If you can hold a tool, we can capture that human dexterity and repeat that.
We call it a reconfigurable robot because we can use 3D printing to actually very quickly build new end effectors. Well, I'm Kent Gilson, and I'm the founder and inventor and robot designer.
I'm Todd Enerson. I'm president and one of the co-founders here at Haddington as well.
When we first started, we actually used a 3mm MDF and a laser, but then we moved into PLA and ABS with early, cheap 3D printers.
We had 7.
We had 7 PLA printers.
And the maintenance to keep them going were probably at 30-35% success rate.
Yeah.
We got our first Markforged Mark II, the continuous carbon fiber one, in October.
It literally took about 2 weeks to actually completely redesign the robot with the Markforged printers.
We bought a Markforged only for the continuous carbon fiber, for the strength and the stiffness. But we were surprised by how, first of all, how tolerant they are. But also the surface finish is shiny. It's really actually pretty. And we can sell a final product that is just Markforged finished parts. It allows us to print things that really shouldn't be printed, but because it's strong enough, we can do. So on our robots, we have 3 harmonic drives, and these give us 52-to-1 gear ratio, and we really need that for torque and precision. But these are really hard to get, and they're really expensive. And so we came up with a solution using Markforged. We're printing what's called a cycloidal drive. We can print really, really strong gears and get the same gear ratio out of that.
I think the time and money we save by switching to and having the family of Markforged printers is the reliability on, we're getting more production off of 1 than we got off of 7.
I don't know how we'd be able to do this without Markforged and the printer. We run the numbers, and there's at no time is there a reason for us to actually go injection molded. Not just for the material properties, but just the economics of actually having a printer. In fact, we can buy a new printer after we sell a single robot, so we can amortize our capital equipment cost over a single robot. That fundamentally changes the financing of the company. We'll never, kind of go into injection molding for the reconfigurable robots. One of the most exciting things about having 3D printing and Markforged printers working in a robot automation, role is the ability to very rapidly create fixturing, and that includes custom grippers. We can actually create a new gripper in just 20-30 minutes in CAD and then have it print out on the Markforged. We can actually take a scan of a particular object, use that geometry to actually build a gripper that's designed just for that object, and then have a custom gripper in a day.
And then we're not stuck with that design either. That's what we can continue to iterate.
It's fundamentally changed the nature of our business and the ability for us to exercise our business plan.